hfo1234yf is a highly efficient, low global warming automotive air conditioning refrigerant developed to replace HFC-134a and meet the requirements of the European MAC directive. With a GWP of 4, hfo1234yf more than meets the requirement for a GWP of less than 150. In contrast, the old refrigerant HFC-134a has a GWP of 1,430. This video will show the new and old refrigerants behave similarly and safely under even the most extreme conditions and present less risk than many other flammable materials under the hood of a car today. 134A is currently in use in more than 500 million vehicles worldwide. The global warming potential of the new refrigerant 1234yf is 99.7% lower than 134A. The rapid adoption of 1234yf would prevent the emission of the equivalent of hundreds of millions of tons of CO2 into the atmosphere. In Germany alone, converting all cars to hfo1234yf would be the same as preventing the CO2 emissions from 2.8 billion liters of gasoline consumed in 1 year. We conducted a number of confirmatory tests to compare the flammability of 134A and 1234yf under real-life and simulated driving conditions at our Buffalo Research Laboratory, a world-class R&D center that has pioneered many environmentally friendly and safe refrigerants over the past several decades. In addition, even more rigorous testing was conducted over more than 3 years by the world's most respected automotive industry groups, including 18 independent laboratories and research institutes. These tests have already established that 1234yf can be safely accommodated through established industry standards and practices for vehicle design, engineering, manufacturing, and service. 1234yf exhibits mild flammability that is significantly lower than some highly flammable materials already in use within automobiles. We ran a series of tests on these materials, which were mixed with 5% oil and sprayed onto a hot metal plate in aerosol form. The plate is heated from underneath and reaches temperatures at or close to 600 degrees centigrade. What you are watching for is any sign of a flame on the surface of the plate where the refrigerants are being sprayed. We tested motor oil, and you can see that it burns. Then we tested automatic transmission fluid. It also burns. Radiator antifreeze also burns. Compressor lubricant, yet another flammable material common in cars that burns. The same is true for brake fluid and diesel fuel. Next, we tested what happens with the two refrigerants under similar conditions. You can see the identical outcomes for 1234yf and 134A. Neither refrigerant burns. The smoke you observe is the oil burning off from the mixture. For all fluids already used under the hood in vehicles, including the ones we've seen in this video that are highly flammable, each automobile manufacturer has defined engineering and design requirements to ensure safe use of these products. In addition, the auto industry has published standards ISO 13043 and SAE J639 that recommend using engineering best practices to manage the risks associated with any automobile refrigerants, including 1234yf. These industry standards are proven and safely used in hundreds of millions of automobiles worldwide. Daimler recently publicized the results of their additional in-house tests of 1234yf. They claim that 1234yf is unsafe because of its flammability, and they intend to stay with 134A for their vehicle models. Our information indicates that Daimler conducted their tests in secrecy without the participation of any reputable third party, and did so 6 years after the original EU MAC directive was issued and on the eve of its implementation. The next test shows what happens when the refrigerant leaks into the engine compartment and comes into contact with hot metal surfaces. We conducted a series of engine runs to identify the highest temperature location in the engine compartment. We did that using infrared thermometry and then placed thermocouples at the highest temperature location. We installed a valve in the refrigerant line to direct the refrigerant leak to that location. We tested both refrigerants, the current product 134A and the new low global warming product 1234yf. As you can see in the video, as the refrigerant leaks onto the hot metal surface, a white cloud of smoke is formed. The smoke was analyzed and found to be oil. It's the same result for both refrigerants. There are no flames. These tests confirm what extensive third-party testing has already shown, that 1234yf is safe for use in automobile air conditioning systems. We cannot afford to lose the environmental benefits from 1234yf that so many others have worked so hard to gain. 1234yf can be used safely as an automobile refrigerant, and it's ready for use by the industry today. For more information, please visit www.1234facts.com or www.1234factin.de.